Today, we're going to take a look at lesson 5.4, which is inequalities in one triangle. So let's take a look. We'll start with example 1. See if I can get this a little bit closer here. Okay. All right. Example 1. Investigate side and angle relationships. So what they're saying is if you have a situation with a side, the corresponding angle that they're going to talk about, always does a very specific thing. So they're starting off with just drawing two different types of triangles. One is just a right triangle, which just means that one of the three angles is a 90-degree angle. And then the other triangle is just, I guess it doesn't say specifically if it's obtuse or acute. It could just be any non-right triangle. So their question that they're asking is, how is the largest angle measure of each triangle related to the side lengths? So for example, with the right triangle, and you could see these little study tips, these little bubbles, right? Make sure you're reading all that information when you're going through here. I'm just going to either read it or just summarize it real quick. So here they're saying in a right triangle, the right angle is the largest angle. Remember, all three angles in a triangle have to add up to 180. So if this one angle is 90, then that means that the other two angles added together have to be 90. So both of those angles are less than 90, right? This has to be less than 90. That has to be less than 90. And when you add them together, it equals 90 degrees. So in a right triangle, automatically that right angle is the largest angle. So the relationship they're talking about is then you're going to look across that triangle. It's the opposite side. So if this is my angle, obviously this side is connected to that right angle and this side is connected to that right angle. So the side that's opposite the right angle is basically the side that doesn't connect this angle. It doesn't touch that angle. So if angle A, that's my right angle, that's obviously the largest angle in this triangle, then the side that's opposite angle A has to be the longest side in the triangle. And here they're just throwing some values on these side lengths just to prove that, right? So angle A is 90 degrees. That's the largest angle. So the side opposite angle A has to be the longest side, okay? It looks like, again, we don't know if this is acute or obtuse. It looks obtuse. That definitely looks larger than 90 degrees. So if angle P is larger than 90 degrees, then that means that angle R and angle Q are definitely the smallest two, right? So just visually, even though they're not giving us actual measurements, angle P is the largest angle, which then what they're trying to emphasize here, then the longest side has to be opposite angle P. So what you're doing is you're starting in this triangle, you're looking at all three vertices, and you're looking for the largest angle, whichever one is the largest. In this case, P is the largest. So the side that's opposite angle P will be the longest side, which is true. Okay. Let's just make sure I didn't miss anything. Angle P, same thing. Okay, and then this is the idea. So for example 1, this is the big idea right here. The largest angle appears to be opposite the longest side. So very, very important. Make sure you remember that. Page 227, at the top, this is theorem 5.9. So if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So what they're saying here is if two sides of a triangle are not congruent, meaning they're not equal to each other, they're not the same length, right? Then the larger angle lies opposite the longer side. So for example, if you're comparing A and C, right? Those two side lengths are obviously not the same. It looks like A is shorter than C. So if A is shorter than C, that means that the angle across from A, which is angle A, has to be smaller than angle C. So let me re-say that again. If you're looking at side lengths A and C, it looks like A is shorter than C. What that's telling you is if A is shorter than C, then angle A, the angle that's opposite that side, angle A has to be smaller than angle C. Or vice versa, right? We could see that C is longer than A when you're comparing the two. C is longer than A. So that means that the angle C has to be larger than angle A, the side that's opposite. Example 2. Again, I know I keep saying this. Make sure you're looking at these little bubbles off to the side. Make sure you're reading through the instructions, and it's just kind of walking yourself through this lesson if you're doing this by yourself. So example 2, you're going to use the theorem from up above, right? Where it's kind of emphasizing if you're dealing with two different sides, the longer side is going to be opposite the larger angle. To support a triangular piece of a float, a brace is placed at the largest angle. So what that's telling me is if they're emphasizing the largest angle, that's going to be opposite the longest side. Okay, but I don't know what they're looking for, so let's keep reading. And a guide wire is placed at the smallest angle. In other words, that's opposite the shortest side, right? So the largest angle is opposite the longest side. The smallest angle is opposite the shortest side. Which angle is the largest? Which angle is the smallest? So if you look at this information, they're saying that this side of the triangle is 10 feet. This side is 13 feet. The bottom is 12. That means out of those three sides, that side, AB, that is the longest side, which means based off the theorem and what we've talked about so far, if that is the longest side, then the angle that's opposite that side has to be the largest angle. So if this side is my longest side, then the angle that's opposite has to be my largest angle. If you look at the three sides, 10 feet looks like it's the shortest. So AC is the shortest side length. What that tells me is that the angle that's opposite that side, angle B, has to be the smallest angle. So angle C is the largest angle because it's opposite the largest side. Angle B is the smallest angle because it's opposite the shortest side. Another theorem on top of 228. The converse. So basically what that's saying is the opposite. If two angles of a triangle are not congruent, so that means if two angles are not the same, then the longer side lies opposite the larger angle. And again, this is exactly what we've been emphasizing this whole time. So let's look over here. It looks like to me, out of these three sides, A, B, and C, it looks like B is the longest side. And it looks like B, since B is the largest, since B is the longest side, then angle B has to be the largest angle. And vice versa. If angle B is the largest angle out of the three, it's kind of a little hard to tell. C looks like it's comparable, but B is definitely the largest. Then side B has to be the longest side. They go hand in hand. So for example 3, prove. Again, we're going to skip these proofs. We're not going to do proofs. So we're going to skip through example 3. So with example 3, they're looking at an indirect proof. And again, I think just because we've always skipped proofs, we're going to keep skipping these. But indirect proof is there's lots of different ways to prove things. But it's kind of a unique type of proof where you're showing that something cannot be false. So that's what they're starting off here. They're starting off with what they're trying to prove, that GH is greater than HJ. And then essentially they're proving that they're trying to prove that it is true, but it ends up proving that it's false. So by an indirect proof, that cannot be true. So again, we're skipping proofs, so don't worry about that. You're not gonna have a question about a proof. But again, if you would like to look into that, if that interests you, I'm more than happy to walk you through one of those. So let me know. Example 4, use theorem 510, which is the one at the top of the page where it was if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. Which side of triangle KLM is the longest? If we look at these two things, the only two things they're giving me are the two angle measurements for L and M. They're not giving me any other side lengths. Of course, we could figure out what K is. Remember, all three angles add up to 180. So what are these? 50 plus 62 is 112. So 68 degrees. So K has to be 68 degrees because these two already add up to 112. So what that tells me is that L is the smallest angle. K is the largest because that's 68 degrees. So knowing that, if K is the largest angle, then I know that the side that's opposite K, which is LM, that has to be the longest side, okay? So because K is the largest angle, the side that's opposite of K is the longest side. Theorem 511, triangle inequality theorem. So we're at the top of page 229. Theorem 511 states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. If this wasn't true, then when you drew a triangle, they wouldn't be able to meet, right? It would look something like, I'll draw kind of a little picture for you real quick. It would look something like one side, another side, and then, right, it wouldn't be able to meet. So that's really important. I mean, it's stating a very basic fact that the sum of the lengths of any two sides has to be longer than the third side because that triangle has to be able to meet, has to be able to join all three vertices. So that's all that's saying. Example 5, use the triangle inequality theorem. And you can kind of see what's happening here. Here's a great one. I didn't even have to sketch one, right? This is an example of what they're trying to emphasize here. So let's take a look at A. Which of the following sets of segments could be the sides of a triangle? So if you're dealing with set 1 versus set 2, what you're looking for is that the sum of the lengths of any two sides has to be greater than that third side. So for example, 19 plus 18 has to be a greater number than 40. So 19 plus 18, that's 37. 37 is not larger than 40. So that would not work. And here's the picture right here, right? You've got the one side plus the other side. It doesn't actually join that third vertice of the longer side. So that's really important. Look at this one. 33 plus 37, that is what, 70? 70 is longer than 66. And you could check all of them, right? 37 plus 66 is 103. 103 is bigger. And then 66 plus 33 is 99, which is bigger. So all three of those side lengths are perfect. When you add any of the two side lengths, their sum is always longer than that third side. And you could see that picture right there in that triangle. Let's see what this is saying down here. Part B of example 5. A triangle has sides that measure 11 and 16. What are the possible lengths of the third side? So here's the picture of what they're trying to say here. Now keep in mind, the rule is that the two side lengths, any two side lengths, it doesn't matter what you're looking at, any two side lengths, their sum has to be longer than that third side length, right? Has to be greater than that third side length. So you can see what they're doing here. They're saying apply that theorem that they talked about at the top of the page, theorem 511, and they're just setting it up, and solving for X. There's different ways you could set that up. It doesn't matter how you set it up. You just want to solve it for X. And the thing is this side always has to be longer. It has to be greater than the sum of the other two. So if I add the other two sides together, it's going to be 11 plus 16 is 27. So we need that side length to apply the theorem 511 from up above. If those two side lengths are 27, the sum of those two side lengths has to be greater, has to be larger, or longer, I should say, longer than that third side. So, at a maximum, it has to be right below 27, right beneath 27. If it can go all the way up to 27, if it could equal 27, it wouldn't be a triangle. It has to be specifically larger or greater than 20 than the other third side. So since these two add up to 27, that means that this side has to be specifically less than 27. But it does have a cap, right? It can't just be any number less than 27. There is a restriction on how short it could be as well. So let's look through here and see what it's saying. If x plus 11 is greater than 16, then x is greater than 5. So we just know that that side length has to be greater than 5. The inequality x plus 16 is greater than 11 is true for all positive values of x. So this inequality only tells you that x is greater than 0, which any distance has to be greater than 0. You can't have a negative distance. And then finally, that third inequality, if 11 plus x is greater than x, then 27 has to be greater than x. So x has to be less than 27. That's a little bit confusing. What they're doing there is just flip-flopping those two. Instead of saying 27 is greater than x, you could just flip-flop them and say that x is less than 27. They mean the exact same thing. So what they did here is they came up with an inequality for each of those sides, right, to solve for each of those sides. So based off of doing those inequalities for each side, again, that second inequality didn't really help. We just knew it had to be a positive number. But the other two did. They specifically said that x has to be greater than 5 and it has to be less than 27. So they call these a compound inequality. It's kind of telling you a piece of information where x has to be between two numbers. So the way you read this is 5 has to be less than x, which is less than 27. So the smallest number that we're looking at starts at 5, but x has to be specifically greater than 5. So it can't be 5. It's not less than or equal to. It's just strictly less than. So anything above 5, like 5.1 or 5.5 or whatever, just as long as it's a little bit larger than 5. And then as long as it's a little bit smaller than 27. So any number between 5 and 27 would work. All right. Wow, that is it. We've had some decent lessons these last couple of weeks. Not too involved, a little bit, not a little bit tricky, but interesting information. Let's see if I can get this thing. There we go. So a concept summary. Inequalities with one triangle. We talked about two different theorems, and they're basically just kind of stating the same information. Where the longest side is opposite the largest angle. And then obviously if that's true for the longest, you could say that for the shortest as well. So that's where that information comes from. And then the triangle inequality theorem, again, remember we had 3 different sides. So we have 3 different inequalities. I don't think I emphasized that enough. So let me go back to example 5 here. When you're looking at this triangle, you want to set up an inequality for each of those side lengths. So x plus 11 has to be greater than 16. 11 plus 16 has to be greater than x. 16 plus x has to be greater than 11. So you've got 3 different situations that are happening there. You want to make sure you set up an inequality for each situation because it has to hold true for all 3 sides. It can't just hold true for one of them. Needs to happen for all 3. All right, so now we will go over to our practice problems. So which angle measure appears to be the smallest in JKL? What can you conclude about the opposite side, about the side opposite that angle? Which angle appears to be the smallest? Get a better picture of that. Man, to be honest, that almost looks like an isosceles triangle to me. It almost looks like that K and J have the same exact angle, right? They look like they're the same values. So we'll talk about this in two different situations. Say this is an isosceles triangle. If K and J, if angle K and angle J were congruent, then that just means that the side that's opposite angle J and the side that's opposite angle K have to also be congruent as well, right? They have to be the same length. If those two angles are the same, then the side that's opposite them have to be the same. If that's not the case, let's say if angle K was the larger of the three. Say if this was like, I don't know, 60, and this was 59. I'm just making something up. If angle K was just a little bit larger than angle J, well, then what that would mean is if angle K was a larger angle, then the side that's opposite angle K would have to be the longer side. So JL would have to be the longer side. So for the next section, it looks like we're going to use this for at least 18, maybe, yep, 18 and 19. So identify the angles of triangle FGH. So FGH. I don't think they're asking for, because we'd have to use trigonometry to actually come up with the angles. I think what they're wanting is just, which side is largest versus smallest. And now that I look ahead, that's what they're looking for. Keep in mind that the largest angle is going to be opposite the longest side, and the smallest angle will be opposite the shortest side. So because the longest side is FH, then that means that angle G is the largest angle. So for 19, that would be angle G. Because the shortest side is GF at 33, that means that the angle that's opposite GF, angle H, would have to be the smallest angle. Identify the sides. Now we're kind of going in the opposite direction. Instead of talking about side lengths corresponding to angles, now we're talking about angles corresponding to sides. So we know that a triangle has 180 degrees. If this angle is 66 and this is 60, that adds up to what, 126? So 180 minus 126 is 54. So that tells me that angle O is 54 degrees. And again, all I did was, I know a triangle is 180, so I subtracted 66, I subtracted 60, it left me with 54. That's the remainder. So what that tells me is that angle N is the largest angle. So that means the longest side will be opposite angle N, which is OP. And then angle O is the smallest angle at 54 degrees. Isn't that what I said? Yeah, 54 degrees, which means that the shortest side would be opposite angle O, which is NP. And then the rest. Determine whether the side lengths could form a triangle. Remember, the big idea here is that the two side lengths, any two side lengths, it doesn't matter which two, any two side lengths, their sum has to be larger than the third side, right? So we'll just kind of go through here, and this is what I'm doing. I'm going to show my thought process here. If these are my three numbers, 13, 15, and 19, 13 plus 15 is 28. Is 28 larger than 9? Yep. 15 plus 9 is 24. Is 24 larger than that third side of 13? Yes. And then which ones haven't I added? 13 and 9. It's 22. Is 22 larger or a larger number than that third side length 15? Yep. So what that tells me is that since that's true, 22 could form a triangle. So that's all I'm doing. I'm going to go ahead and keep checking these. 8 plus 15 is definitely larger than 7. So that's good to go. 15 plus 7 is definitely larger than 8. But the last side, 8 plus 7, that's 15. 15 is not larger than 15. If you go back to this theorem, it specifically states that it has to be greater than, it has to be larger than that third side. So for number 23, that would not form a triangle. 24, 35 plus 20 is greater than 11. 20 plus 11 is not greater than 35. 20 plus 11 is 31. Since that doesn't hold true, then 24 is not a triangle. You don't have to keep checking them. As long as you find one side length that doesn't work, it's not a triangle. 25, 65 plus 32 is definitely larger than 40. 32 plus 40 is larger than that third side. And then 65 plus 40 is larger than that third side. So, yep, 25 would form a triangle. Given two sides of a triangle, determine the range of possible lengths of the third side. So this is talking about that theorem, which all three theorems are very, very similar to each other. Just talking about the longest side is opposite the largest angle. This is the one where if we were given, so let me go ahead and draw this out, 26, if I drew two side lengths of a triangle, and I labeled one of them 10 and the other one 12. This is what we have here. And the question we're answering is determine the range of possible lengths of the third side. So remember, we're just going to call this third side here that we don't know. We're going to call that X. So this is the one where you're going to come up with an inequality for each situation. Remember, two side lengths added together, their sum, not their thumb, their sum has to be larger or greater than that third side length. So we'll go ahead and do that. So 10 plus 12 has to be greater than X, has to be larger than that third side. So there's my first one. The second one, we'll do 12 plus X, has to be greater than that third side of 10. And then the third one, X plus 10, has to be greater than that third side of 12. So let's go ahead and solve these. 10 plus 22, or 10 plus 12 is 22. I don't like leaving inequalities like this. I like to kind of write them with the variable first. So what I'm going to do is I'm going to take this inequality and I'm going to flip both sides. So it's going to be an X first, then a 22 first. But if I do that, if I flip those two sides, I need to flip my inequality sign. So my greater than becomes less than. So there's one of them. Here, I'm going to go ahead and subtract 12 from both sides. So I get X is greater than -2. And then the third one, I subtract 10 from both sides and I get X is greater than 2.